Hello everyone, I am Raj. I am from IIT Agartala, and today I am going to discuss on the topic hybridization. So let us first know what is hybridization. Hybridization is a hypothetical concept in which intermixing of different atomic orbital nearly equal energy takes place and to give new hybrid orbitals which have identical in shape, size and energy. So we understand the hybridization with the help of an example. So here we have taken the example of CH4 molecule. So we will find the hybridization step by step. So in the first step we have drawn the Lewis structure. So here in the first step we have drawn the Lewis structure of CH4 molecules, that is central atom is C and 4 hydrogen atom is attached to the central atom through the sigma bond. Now in the next step we will draw the electronic configuration of the central atom. So here we have drawn the electronic configuration of the central atom in the ground state, that is 1s2, 2s2 and 2p2, and we fill the electron according to the Hoffa principle, Pauli-Exclusion principle and Hund's rule. So here we fill the electron in the orbital. Now in the next step we will draw the electronic configuration of the central atom, that is carbon, in the excited state if needed, so that the total unpaired electron is equal to the total number of bonds. So here we have also drawn, because you can see that there are 4 bonds but total unpaired electron is only 2, so it will not form a stable bond. So we will excite it and draw the electronic configuration in the excited state of the carbon. So electronic configuration is in the excited state 1s2, 2s1 and 2p3, and we fill the electron in the orbitals. Now in the next step we will intermix the different atomic orbitals. So here we have also mixed the different atomic orbitals, and after intermixing it will form hybridized sp3 orbitals, and that is equal to the atom number of the atomic orbital in the hybridized orbitals. So they have also in the identical in shape, size and energy. So in this way we can calculate the hybridization of CH4 molecule step by step, that is sp3. But if we want to calculate the hybridization very quickly, then we have to go through the approach of a stage number approach. So here a stage number is denoted by Z, and Z is equal to half into number of valence electron of the central atom plus number of monovalent atom plus negative charge if any minus positive charge if any. So before taking the example of NH3 molecules to understand the stage number concept, here we will write the hybridization corresponding to the stage number in a table form. So here we have also write the stage number and hybridization. So corresponding to stage number 2, hybridization is sp, and corresponding to stage number 3, hybridization is sp2, corresponding to stage number 4, hybridization is sp3, 5 sp3d, 6 sp3d2 and 7 sp3d3. So in this way we have written all the stage number and corresponding hybridization. So now we will take an example to understand the stage number concept. So here also we have taken the example of NH3 molecules. So in the NH3 molecules we have drawn the Lewis structure of NH3 molecules, that is 1 lone pair and 3 hydrogen atom attached to the nitrogen atom through the sigma bond. Now we will draw the electronic configuration of the central atom, that is nitrogen. So here we have also draw the electronic configuration in the ground state of the nitrogen atom. So that is 1s2, 2s2 and 2p3, and we will also fill the electron in the atomic orbitals according to the Hoffa principle, Pauli-Exclusion principle and Hund's rule. So here also we fill the electron, and you can see that there are 3 bonds and 3 unpaired electrons, so it will form a stable bond. Now we will find the valence electron. So number of valence electron, you can see that total number of valence electron is 2s2 and 2p3, that is equal to 5. and number of monovalent atom. You can see there are 3 hydrogen atom attached to the nitrogen atom, that is also equal to 3, and there is no any negative charge, so negative charge is equal to 0, and also there is no any positive charge to the central atom or in the molecule, so also the positive charge will be also 0. Now we will move towards the steric number. So we have written the formula here, the steric number, and we will put all the value in the steric number formula. So here we can put Z is equal to half into number of valence and electron, that is equal to 5, plus number of monovalent atom, that is equal to 3, and negative charge is equal to 0, and positive charge is equal to also 0. Here after calculating we get 8/2, that is equal to 4, and we will now move towards the steric number table, that is corresponding to 4 steric number, hybridization is sp3. So in this way we can get the hybridization of sp3 molecules, that is sp3. Thanks.